All right, Brandon Clayton here, the Algebra Guy. As you see on your screen, today's discussion will be over Pythagorean Theorem. And if you know anything about Pythagorean Theorem, you know we're about to talk about triangles, angles, and all that. So let's buckle up and get into it. So our questions we want to answer today are, by the end of this video, you'll be able to use the properties of angles. Answer the question, what are supplementary and complementary angles? Use the properties of triangles and use the Pythagorean theorem. So let's go ahead and get into our problem. So an angle is formed by two rays. What is an angle? An angle is formed by two rays. So if you remember what a ray is, or if you don't know what a ray is just has an end point and an arrow that goes on forever. That's a ray. So angle is formed by two rays that share a common endpoint. So you have one ray there, and another ray has an endpoint that they're sharing. So makes an angle right here. Each ray is called a side of the angle, and the common endpoint is called the vertex. So we'll call this, maybe call this A, vertex A. An angle is named by its vertex in the figure below. Let me pull up that figure. Angle A is the angle with the vertex point. So here's angle A right here. Here's an interesting angle to start out with in our discussion. So you've heard of a 90-degree angle, right? So a 90-degree goes straight up and has this angle here. Well, this whole thing right here is 180. So that makes a straight line, as you can see. So let's remember that because we're going to need to know that for our discussion today. What's the difference between supplementary and complementary angles? So put simply, supplementary angles are angles that add up to 180 degrees, while complementary angles, so there's a supplementary right here, while complementary angles add up to 90 degrees. The way I like to remember that is if you know anything about food supplements complete your diet. So this 180 makes it nice and straight, so it completes my diet. That's why I think of a supplement. It helps complete. Maybe I needed some more protein or magnesium, but it helps complete it. So I take supplements for that purpose. So that helps me remember the difference between supplement and complement. Let's start our first problem. An angle measures 40 degrees. What's its supplement and what's its complement? So if I have an angle, let's make an angle. I want to make a straight line, so I'm going to use this. Bam and bam. So let's say that this is 40 degrees. 40 degrees. I want its supplement. So its supplement means I read the problem, identify what they're asking for, which is the supplementary angle and the complementary angle. And I'm looking for, let's call it X. I'm looking for the supplement. And I'm looking for the complement. I don't really want to call the complement a different one, but I guess I could. So complement, I guess we can call that Y. So to find this, I know that I need to add two things together to get my supplement. So I'm going to say for supplement, it's going to be my 40 degrees plus some angle is going to give me 180. And for my complement, it's going to be 40 degrees plus some other angle to get 90. So to get those is pretty simple, right? You're just going to subtract 40 on both sides. And this one's going to give us a 140 degree angle while subtracting 40 over here will leave us with 50 degree angle. So that's pretty straightforward there. Two angles are supplementary. All right, so we already know just from reading, so we're doing our reading part. Two angles add up to 180. The larger angle is 30 degrees more than the smaller angle. Find the measure of both angles. All right, so this one takes a little bit more thought. So I have some angle, let's say the smaller angle, we'll call that angle, we'll just call it X. And we have another angle. The larger angle is 30 degrees more than the smaller. So the larger angle, we're going to call that one X plus is 30 more. So X plus 30. Now, what do we know about this? So we read it. We identify what we're looking for. We want both angles. We want both of these angles, the large and the small. We identified these with variables. and we want to translate into some kind of equation, right? So we got two angles that are supplementary. So this helping verb tells me that there's going to be equal to supplementary 180 degrees. So I know these two angles, when I add them up, x plus, here's my smaller angle, plus the larger angle, x plus 30, is going to equal 180. So this is what I need. So we got an angle that's 30 degrees more than the smaller, and they both add up to 180. So this is how you set it up. So we got that set up. Let's go ahead and solve it now. X and x gives us 2x. And we're going to subtract 30. Gives us 2x equals 150. Dividing both sides by 2 leaves us with 75. So did we answer our question? Well, we solved it and we got an answer. Now let's check to make sure the answer is answering the question. What's the measure of both angles? Well, the smaller angle is just x. That's going to be 75 degrees. The larger angle is going to be x plus 30, so it's 75 plus 30, which gives me 105 degrees. Now I can check my answer by adding these up and making sure they equal 180, and yes they do, and making sure they're 30 degrees apart, which they are. And so that's how I know I got it right. And that's how you're going to set up and solve these. I'm going to give you a couple more that's similar to that, so keep your heads up and pause it when you see it and try to work it yourself. But before I do, let's talk about the attributes of a triangle, because we're going to get into the attributes of a triangle in Pythagorean eventually here. So what do we already know? We know that a triangle has three sides and three angles, right? So A, B, C, my sides, and capital A, B, C, my angles. Triangles are named by their vertices, so I would name this triangle A, B, C. And yes, you could name it triangle B, C, A. It doesn't matter the order. So it's the same triangle. The three angles of a triangle are related in a special way. Their sum is 180. Did you know that? So if I add up all the angles of a triangle, it's always going to give me 180. And if you go deeper into geometry, you'll find that it's not always true in different types of geometry. Only in what's called Euclidean geometry is this going to be true. Spherical geometry, you're going to have it more than 180. Hyperbolic, I think, is less. But just know that there's others out there. But for the most part, we deal with two-dimensional space, Euclidean geometry, so all the time it's going to be 180 for our purposes. So we read this triangle ABC. We label each side with a lowercase letter to match the uppercase letter opposite the vertex. So here's the capital C, lowercase c. Capital A on the opposite, lowercase a. All right, let's see if we can work this one. The measure of two angles of a triangle are 55 and 62. Find the measure of the third angle. Sometimes it's great to draw a picture, so I'm going to do that to help us get the idea. And it's not drawn to scale, so don't try to. It looks equilateral, unbelievable actually. I just kind of threw that up there. So this is 55 degrees. There's one that's 82 degrees. And we're looking for this one. We're looking for one that's missing. So what did I do? I read it. I figured out the question they want. We want the third angle, and I labeled it x. So let's translate this into a equation that we can answer. So we know that three angles add up to 180. 55 plus 82 plus x is going to equal 180. Now all I got to do is do the work. So got that. Now let's go ahead and solve it. Take out my calculator, and we'll do 180 minus 55 minus 82, and that gives us 43. And you could have done this a couple of ways. You could have added those and then subtracted it from 180. It's going to be the same thing. So you can check that again by plugging it in there and make sure it adds up to 180. And did we answer our question? Yep, they just wanted the third angle. We got 43. Make it more specific, 43 degrees. All right, some triangles have a special name, as you can see, and you're probably already aware of this one because this is probably one of the most popular triangles, is the right triangle. A right triangle has a 90-degree angle, as you see with this little square, which is often marked with that symbol we see here. If we know that a triangle is a right angle, we know that one of the angles is 90. So that helps us if we're solving a problem like this, where it says we have a right triangle and another angle that's 90. Now, I don't think I can draw a right triangle with my tool, so I'm kind of going to sketch one here. Beautiful. I'm going to put a little angle here so we know. So we got this one at 90 degrees. We got another angle at 28 degrees, and it says we're looking for the third. So I know what we're looking for, and I'm going to call it X. Let's put it in I meant to put a check. Let's put it in an equation. 90 degrees plus 28 degrees is plus, I'm sorry, not equal, but it's plus some other angle should add up to 180. So again, I could take out my calculator and do 180 minus 90 minus 28. And I get 62. So now I see that X is 62. I could add this up. I can see that 62 and 28 does give me 90. 90 and 90 is 180. So I solved it, I checked it, and I'm going to put degrees on it to make sure I'm answering the question when you're talking about an angle. And that's it. We're done on that one. All right, the measure of one angle of a right triangle is 20 more than the measure of the smallest angle. So we're still dealing with a right triangle, but now we have this situation where we're dealing with something that's more than another angle. So oh, that's a terrible line. Okay, I can definitely do better than that. Why didn't I think of just using lines in the beginning? All right, so let's use a line. All right, line. Bam, so much better. Why did I not think of this? All right, so got that. Bam, much more beautiful. There's my right angle. I know that one is, so we read the problem. We want all three angles. So we know what we want. And what are we looking for? All three angles. So I know one is 90, so I'm almost done, right? At least a third of the way done. I know one angle is going to be X. Measure one angle of a right triangle is 20 more than the measure of the smallest. So let's say this is the smallest, is X, and the other is 20 more than X. So it's X, let's say X plus 20, because it's 20 more. So there we go. We got all our angles. But they actually want to know what the answer is, right? So how are we going to give an equation for this one? So we're going to say all these add up to 90 plus X plus X plus 20. So I got one angle here, another angle here, another angle here, all add up to 180. When I add these up, I can subtract 90 actually and make this a little bit easier. At least the number smaller. Put my two x's together to give me 2x plus 20. 180 minus that 90 is 90. Subtract 20. Gives me 2x. And x equals 35. So now I know that this angle is 35 degrees. So if that's 35 degrees, this must be x equals 35. So 35 plus 20 is 55 degrees. And I kind of eyeball this to say, does that look right? These should add up to 90. Let's see. Yep, it looks like right. 3 and 5 is 8, plus 5 and 5 is 10, which is going to make that 90. 90 and 90 is 180. So solved it, checked it, makes sense. Got my degrees on it. We're good to go. All right, so what about similar triangles? This comes up also. When we use a map to plan a trip, a sketch, build a bookcase, or sew a pattern or dress, we're often using similar figures. In geometry, if two figures have exactly the same shape but different sizes, they're said to be similar. One is a scale model of the other. The corresponding sides of the two figures have the same ratio, and all the corresponding angles have the same exact measure. So what are they saying? These angles here, let me use a different color. This angle, let's put a little one line, is going to be equal to this angle. This angle is going to be equal to this angle. and this angle is going to be equal to this angle. They'll be exactly the same if they're similar. That's the key, right? If they're similar. What about the sides? The sides that correspond, like this side corresponds with this side, we're going to say that's 16 for every 4, as you see here, is the same thing as 12 for every 3. They're all equal. Why? Because 16 divided by 4 is 4, 12 divided by 3 is 4, and 20 divided by 5 is, yep, you guessed it, 20 divided by 5 is 4. And that's what they're really trying to say, is that you're going to always get the same answer between these two triangles, exact same answer for the angles, but the ratio is going to be the same when looking at the sides. So let's see if we got it. Find the links, or let me read the problem. Triangle ABC right here and triangle XYZ are similar. Okay, that's what we needed to know. They are similar. So there's some things that we know is true. We know the corresponding angles are equal, and the corresponding sides are ratios of one another, equal ratios. All right, the lengths of the two sides are shown. Find the lengths of the third side. So we got two sides on these triangles, but one side is missing. So let's set up a ratio to help us find it. We can say that 4 is to 3, so 4 for every 3 is equal. So this 4 to this 3, and let's say I'm looking for A. I can say A is equal to A over 4.5. So this is the setup I need in order to solve this. Well, how's this going to help us? Well, we can do what's called cross product and multiply 3 times A to get 3A and set that equal to the cross product of 4 times 4.5. So let's get our calculator out. 4.4 4 times 4.5 is 18. So divide by 3 on both sides, and you get 6. A equals 6. Did we answer our question? Well, halfway. So we know what A is. A is now 6. But what is Y? Well, we can still use this relationship between 4 and 3. We can say 4 over 3 is the same thing as Y is here, so this corresponds to Y on this side, 3.2 over Y. And I just want to point out one thing. I didn't want to erase all of that. My goodness. 4 over 3 equals. If you start from this triangle, like I did at the top, 4 to 3, you have to go back here 3.2 to Y. You can't go 4 to 3 and then Y to 3.2. You have to stay consistent. All right, so again, how do we solve this? We can cross multiply. 3.32, I'm sorry, 3 times 3.2 is 9.6. 9.6. All right, so got that one, and then we got 4y. All right, so I need to find out what y equals by dividing by 4. And that's 2.4. So did we answer our question? So let's see, we got 2.4 here. Find the lengths of the third side of each triangle. Yeah, we got the third side here and the third side here, 6 and 2.4. All right, lastly, Pythagorean theorem finally. The Pythagorean theorem is a special property of right triangles that's been used since ancient times. I mean, this thing goes back, I believe, yeah, 500 BC. I think even to the 2000, 3000 BC, if I remember reading something correctly. It is named after the Greek philosopher and mathematician Pythagoras, who lived around 500 BC. Remember that a right triangle has 90 degrees, which we usually mark with a small square in the corner. The side of the triangle opposite 90 is called the hypotenuse, and the other side is called legs. So here's my right angle. The opposite side is called the what? Let's look for it in here. Hypotenuse. And the other sides are called legs. It's pretty easy. So with a right triangle and using Pythagorean theorem, this formula is necessary. A squared plus b squared equals c squared, where c is the length of the hypotenuse, a are the lengths of the legs. So pretty easy. When is this useful? When you given two, and when you have a right triangle and you're given two sides but can't find the other, you can use Pythagorean theorem to find that. All right, what about this? This is going to be, I know my formula is a squared plus b squared equals c squared. And I'm going to say a is 3 squared. And I'm looking for c squared. Notice I didn't add it up and put a number there because then I won't have a variable to solve for. So I had to learn it the hard way. I was like, where is my variable? So this is going to give me 9 plus 16 equals c squared. 16 plus 9 is 25. C squared. To get c by itself instead of c squared, I'm going to do the square root of c squared, and the square root of 25 giving me c equals 5. So now I know that c, my side c, my hypotenuse equals 5. All right, so here's another one in a slightly different order. So my legs will go A, B. My C is always hypotenuse. Now you can flip the A and B, but don't mess with the C. C always has to be in the place of your hypotenuse. So we're going to do 5 squared plus 13 squared. 13 squared. Actually, no, we're not. I just messed it up. A squared plus B squared. Here's A, here's B. There's nothing there for B, so I have to do B squared equals 13 squared, which is 169. Yes. So I almost thought this was a 6. All right, so I need to do 5 squared. I'm going to solve for B. So we're going to get b squared equals 169 minus 25, which is 144. To get rid of that squared, I need to do the square root. And the square root. Square root of b squared is just b. Square root of 144 is 144. I think I got time for one more. And I kind of like that one because it looks like a word problem. Kevin is building a gazebo and wants to brace each corner by placing a 10-inch wooden bracket diagonally. So here you go. Here's this 10-inch wooden bracket diagonally. How far below the corner should he fasten? So how far down? What is this place here? That's what he's wondering. It's his question. If he wants the distances from the corner of each to be the same. So if you got these two distances or the corner the same, what kind of triangle do you have? Well, we have an isosceles. Great. So it's something. How are we going to set this up? We read it. What are we looking for? We're looking for the distance of one of the sides. Let's make sure. Distance from the corner to how far below the corner? Yeah. So they want just distance of one of the sides. All right. So I know what I'm looking for now. I had to reread it. I'm going to give it a variable. I'm going to call it. I'm looking for x, and that's going to be distance of side. Then we're going to set it up so we can solve it. So I know that, let's call this side that we're missing x, right? So let's call this x. Well, if they're the same, this can be x also. So I know that x squared, let me slow down a little bit. So we know that a squared plus b squared equals c squared. So I want to figure out one of the legs. And I know that both of them are the same, so I can just make them both x. X squared plus something else squared is going to give me the hypotenuse. And they gave me that. That's going to be 10. So now I need to find this by adding these up. 2x squared equals 10. Divide them by 2. X squared equals 8. All right, and I want to find x because that's just the area right here. I don't want all this area. I want the length. So I'm going to do the square root of a squared. It gives me x equals the square root of 8. And we'll learn later that that's the same thing, I think, as the 2 square root of 2. All right, now I think that does it. Did we do everything we sought to do? Use the properties of angles, use the properties of triangles, and use the Pythagorean theorem. So we did all those, guys. Thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next time.